All right, good morning. Hope you're doing well. Happy Thursday. I just saw you yesterday. Just a couple reminders. We're going to have exam P9 on Friday at 8 a.m. Okay, so P9, if you have any questions, feel free to ask me now. Any questions about P9? Remember that the best way to study for these exams are to do the problems online with the globes, because the exams look exactly like those problems. So if you're practicing with those globes, there's no way to fail the test, that's for sure. You're only guaranteed an A if you know how to do those problems online. So make sure you're doing those, especially to understand how to input the answers in the software for the exam. P9.
Can you do problem 65?
Okay, what page are you on?
138.
Okay, 138.65.
Mm-hmm.
Okay, this is the absolute value of 2x plus 6 divided by 3, and it's the inequality is less than 2. And remember the steps with this. You want to isolate the absolute value, and it is isolated. And so we're good to go. And so what we're going to do is, since it's isolated, the first we have to decide, is this an and or an or? And that's less than or equal to. And they want us to solve it. So what you're going to do is you have to write a compound sentence. So you're going to have 2x plus 6 divided by 3 is less than 2. And in the negative case is 2x plus 6 divided by 3 is less than 2. So those are your two cases. This is the only way to get rid of the bars. So I always think it's interesting when I grade this test. I always wonder why students keep the bars around or they don't write the compound sentence. So I'm going to say this one more time. In order to get rid of the bars, you must write an and or an or. It's a compound sentence. So what I'm going to do is I'm just going to get rid of this fraction immediately. So remember what we did before? We multiply by the common denominator. So I'm going to multiply both sides by 3, and I'm not going to show it. So multiply by 3 and multiply by 3. So just like before, we eliminated the fractions in one step. So now we're going to solve this, and I notice that these are all divisible by 2. So I'm just going to divide by 2, divide by 2, divide by 2. Now you don't have to do that, but whenever you can simplify, we want to, right? So when you subtract 3, you get 0. So remember, this is an and, so we're going to go over here, and I'm not going to mess with that negative. I'm going to multiply both sides by a -1. So when I multiply by a -1, it goes away. When I multiply by a negative, the symbol flips. So remember that rule? Whenever you multiply or divide both sides of an inequality by a negative, you must flip the symbol. And this would be a -2.
Hey, Ms. Burt.
So, yeah.
Wait, what are we doing? Because I barely joined.
We're doing a problem on page 138.65. So
Okay.
now we're going to multiply both sides by 3. So we have 2x plus 6 multiplying by 3. Change that. Multiply by 3 is a -6. So once again, I'm going to divide by 2, divide by 2, divide by 2. And now when I subtract 3, I get a negative, and a negative is a -6. So now I'm not sure how the computer is going to write this. So that's why you have to practice the problem. So I'll show you a couple ways they could write it. They could just write it like this, which I highly doubt. It's an and, so they could write it as a compound inequality, which I think they probably will do. So it's x is less than 0 and x is greater than -6. They could write it in interval notation, which would be open on -6 up to 0. So it's one of those three ways they're going to write it. And I have a feeling they're going to write it in interval notation. It's going to be one of these two.
Miss Birch, can you go up a little bit? I'm sorry.
So Brandon, did you follow that? So,
Yes.
yeah, what you're going to have to do is look at those globe problems and see which way they're going to write this on the exam. I think they're going to write it this way. They're going to write it one of these two ways, and they're probably going to write it in interval notation. Now, remember, you can only write an and like this. You cannot write an or like this. So ands always have these less thans or less than or equal to. Okay, anything else right now? We're doing some problems for the exam on Friday morning. It's the P9 exam, which focuses on linear inequalities and absolute value inequalities. So I just did a problem. We're going to be talking about transformations today and working in groups, teams. So, okay, last call. Anybody want me to work a problem for P9?
Could we do 31? No, 33.
Yeah, yeah, you should probably know how to do that. Okay, so 33 is 8x minus 11. And it's 8x minus 11 is less than or equal to 3x. And what does that say, plus 6? I'm sorry, you guys, when I have to look down at my book, it would help if somebody read the problem to me, so I don't have to keep looking down. Is it minus 13? Is this correct?
Yeah.
All right. So I like to put the variable on the biggest variable side. That means the numbers would go over here. So if the numbers go over there, I'm going to add 11 to both sides, which is 8x is less than or equal to 3x, and a negative and a positive depends, and that's -2. So now I'm going to subtract 3x from both sides. So that would be 5x is less than or equal to -2. And now when I divide by 5, you do not flip the symbol because there's a negative over here, but we didn't multiply both sides of the inequality by a negative. See, you only flip the symbol when you multiply both sides of the inequality by a negative. We did not do that. So the symbol stays the same, and this is the answer. Hold on, that's not the answer. Now, they're probably not going to write the answer like that. So let's read the directions. It says use interval notation. And then it says graph it on a number line. So this means all the solutions are less than. So that means negative infinity. And this would be -2/5 closed because it has an equal. If it was strictly less than, it would be open. And now we graph. So I'm going to put numbers somewhere in between here. So this number, -2/5, is between 0 and -1. right? So I'm going to do -3, -2, -1, 0, 1, 2, 3. All right. So the negative infinity means it's going forever to the left, and you need to color in the arrow because that means forever, right? And do you guys remember what this means? 2 out of 5 parts. So you draw 5 parts, like 5 pieces of cake, 5 equal pieces, 1, 2, 3, 4, 5, and this would be -2/5. So over here, you would draw the 5 equal parts, and -2/5 would be there, and you draw. So this represents closed on -2/5 to negative infinity, and this represents closed on -2/5 to negative infinity. All right, any other questions? Last call. Any conceptual questions?
That makes sense, but like we have to write 2 graph. Like, do you think there'll be 2? Well, never mind. I'll just do those problems on the.
Wait, what'd you say, Bernie?
No, I was wondering, like, on the test, we'll be having to like graph as well.
Yeah, because
Okay.
the directions here say in all the exercises use interval notation and graph.
Okay.
So the test looks exactly like your book. I'm taking these problems right out of the database that was purchased with your book. So, you know, this is a Blitzer book. This is a Blitzer database that I'm taking these problems out of. So the directions are exactly like the ones in your book. I'm not taking them from somewhere else. I'm taking them straight from this book. So this is what I've been complaining about with the math department. People want to use all these different curriculums. That's fine. I don't care. But when you start testing students on problems that are over here and over there, and students aren't being tested on problems they're not used to seeing, I don't think that's right. I think students, when they're getting a grade, should be tested on what they've seen.
Ms. Birch.
We shouldn't be using different vocabulary. If we give students assignments, we should test them on those types of problems and that type of wording. Go ahead.
No, I was gonna ask you. So still, obviously, you know, do the problems that you assign, but they focus more on like the first 4 problems for each part.
I would say like the first, like, are you looking on page 138?
Yeah.
I would focus on like 29 through like 34. I would focus on 49 through like 52, maybe 59 through 70. So depending on the problem sets, if the problem sets are bigger, you might get more problems. You get what I'm saying?
Yeah, that makes sense.
But I'm not going into the last 10 or 20 problems.
Yeah, I get you.
You know, you got to stay focused on the first chunk of problems.
Okay.
But no, I'm not just putting problems 1 and 2.
Yeah.
You got to, yeah. All right, I'm going to go on then.
Wait,
Now,
Mr.
yes,
I have a question.
Go ahead.
Can you do number 53?
Okay, I lost my page. What was the page again?
It's 138.
Okay, 138, 53?
Yeah.
Okay. Okay, this is an and because it's a compound sentence. And it's 2x minus 1 is less than, what is that, 1? I keep writing down the wrong problems. 2x, is it less than or equal to -5? Is that right, guys?
Yeah.
Okay, now only an and, remember I said only an and can be written like that? Well, that's what I meant. Only an and can be written like that. So what we're going to do is we're going to write two statements. So here's one of them. So we're going to say 2x minus 1 is greater than negative 11, because remember we're reading it this way. So 2x minus 1 is greater than negative 11, and you're going to read it this way. 2x minus 1 is less than or equal to negative 5. Okay, now please unmute yourself and tell me, do you get this or not? Like, do you get how I wrote it?
Yeah, you just split like two different ones.
But do you see the symbols though? 2x minus 1 is greater. See how it's greater?
Yeah, the
Yeah, I
negative,
get it.
which makes sense. Yeah.
Okay, so now we're just gonna solve it. So when you add 1, you get negative 10, and you divide by 2, do not flip the symbol. Over here, you add 1, and when you add 1, you get negative 4. Do not flip the symbol. And so there you go. And like I said, they're going to write the answer, probably in interval notation. So you just read this. X is greater than negative 5. So X is greater than negative 5. And X is less than or equal to negative 2. And so this is going to be open on negative 5 up to negative 2 closed. And I bet you $10 that's how they're going to write the answer. This is number 53, right? I'm just going to look it up in the back of the book just to make sure I'm giving you the right answers. P9. P9, where are you? Oh, way off here. Sorry, hold on a second. All right, P9, number 53. It's exactly this. This is exactly how they wrote it. And they did not ask us to graph. They just asked us to solve. So this is saying that all the solutions are greater than negative 5. So negative 3 is a solution, negative 4 is a solution, negative 4.2 is a solution, negative 2 is a solution, negative 2.1 is a solution, negative 2 and a fourth is, so all the solutions are in between there, and there's infinite ones. This is an interval. So every number in this interval makes this true, and it means it's a solution. Okay, did that help? Yes, no?
Yeah, thank you.
Okay, no problem. All right, can I go on then? Okay, listen up. If you were absent yesterday, you have to watch the YouTube video on my channel. I taught a very important lesson that's going to affect like 12 or more functions in the future that we're going to do. So you must know what I was talking about yesterday, and I'm going to go over some things because I know I went right up to the end of the period, but I'm going to make sure that we're clear about everything if you were in class yesterday. If you weren't, you must watch the video from yesterday. All right. Now, first of all, we looked at A, B, H, and K, and we specifically looked at the quadratic. So I put the parent functions, all the parents, I put them in your lesson, but I also put them in the material section. So in the future, you can just look at materials. But if you have a printer, I recommend that you print out the parents. Second of all, I put the quadratic transformations in the materials also. I put it in your lesson, but I also put it in materials so you could have that in the future also. If you can print that out, print it out, because you're going to use that quadratic transformations for cubic, quartic, quintic transformations, logarithmic, exponential transformations, absolute value, cube root, cubic. I mean, you're just using it for everything. So you need to know that transformation sheet. In other words, what does A do? A, do it with me, please. A is a vertical stretch or a vertical compression. It also reflects over the x-axis. Okay, what does B do? B is a horizontal, do it with me, please, horizontal stretch or compression, and it reflects over the y-axis. All right, now H moves the graph left or right. It doesn't change its shape. And K moves the graph up or down, and it doesn't change its shape. Those are translations. So I want to show you something. Watch this. That is the form of the quadratic. Everything in here is horizontal. Even the reflection. Watch my arm. When you reflect over the Y, look at my arm. Is my arm going left and right? So everything inside a square, everything inside a cube, everything inside the logarithm, everything inside the cubic, everything inside the cube root, everything inside the absolute value, everything inside is horizontal. Horizontal stretch or compression. Translate left or right. Reflect negative over the y-axis. All right, stay with me. Everything outside is vertical, right? So vertical stretch or compression. Translate up or down. Reflect over the x-axis. So here's what you need to know. Horizontal has to do with x. Vertical has to do with y. So what does that mean? If you do something on the inside, make sure you do it to the x. If you do something on the outside, make sure you do it to the y. All right, now, yesterday, I gave you an order, and I told you you must follow the order, you're going to get the wrong graphs. So what was the order? What's number one? Go ahead.
Number one's left and right.
Right. What's number two?
Stretches, compressions.
Stretches and compressions. What's number three?
Reflections.
Yep. And what's number four?
Up and down.
All right. You guys ready to do what we're going to do? We're going to do some problems. And then we're going to go into our Math Wizard teams and work on the exam, which is a practice. Okay, here we go. You're going to do three things, ladies and gentlemen. You're going to state the transformation in the correct order. You're going to show the transformational points of the parent, and you're going to graph. All right? All right, here we go. What are you going to do first?
Left one.
Right. Now, remember what I said, the form, they'll have minuses in them. So this is really minus a negative 1, right? That's left 1. Right? Okay. What's next? A stretch or compression, right? Well, there are none. This is a 1 and that's a 1. So now there's a reflection. What reflection is it? Is this a reflect over the X or reflect over the Y? It's outside. It's outside. Look at my arm. It's outside. Reflect over the X. Then what's left? Up or down?
Down.
Down 4. Good. All right, now, do you guys remember? You should already have the points memorized for the quadratic. Do you remember the points we're using? You can use any points on the parent, but we picked the nicest points. So do you guys remember the points? And if you forget them, you can just put them into the parent and figure it out yourself. Right? Put a negative 1 in, put a 0 in, put a 1 in. Okay, here we go. Left 1 means subtract from the X. So subtract from the X would be negative 2. Subtract 1 from the X would be negative 1. Subtract 1 would be 0. The Y's stay the same. Next, reflect X. Well, watch my arm. Isn't a reflect X vertical? So shouldn't I negate the Y? So when you reflect X, you negate the Y. So the X stays the same. That's going to be negative 1. That's going to be negative 0. That's going to be, which is just 0, negative 1. And last but not least, down 4 means subtract 4 from the Y. So the X stays the same. Subtract 4 would be negative 5. Subtract 4 would be negative 4. Subtract 4 would be negative 5, and we're done. Now, I do realize that this seems like a lot of work, but when you get good at this, you're going to do it so fast. And not only that, but you will actually be able to see the graph in your mind before you even do it. So like on the SAT, if you have a multiple choice test, you're going to be able to just look and go, oh, it's D, without even doing any work. All right, here we go. Left 2, down 5. Left 1, down 4. 0, down 5. Now, does that look like it was shifted left from the, remember the parent looks like this. Does it look like the parent was shifted left? Does it look like it was reflected over the X and moved down? Yes or no? Yes.
Yes.
So we have a high level of confidence we did it right. So you want to have confidence we did it right. Can I erase this one? This is a more difficult one because it had 3 transformations. If you only have 1 transformation or 2, it's not a big deal. Okay, now I can't remember. Did I show you B yesterday? Did I show you what was going on with B?
Can you go over that one more time? I wrote it down, but I just want you to like refresh it.
Yeah, let's do a problem. Now, remember B is always multiplied to X. You have to take the reciprocal. So state the transformation in the correct order. Is there a left or right? Is there an H? No. Okay. Is there a stretch or compression? So when you flip it, what is it? See, it looks like a horizontal compression because it's a proper fraction, but it's not. It's a horizontal what?
Stretch.
Stretch by 3.
Uh-huh. And up 2. So you just have to remember when you have B, just take the reciprocal. B always, it looks wrong. So just take the reciprocal. Now, you know what a horizontal stretch looks like, right? It looks like this. So we're going to take the parabola and stretch it out. Okay, let's see what happens here. So your parabola is left 1, up 1, 0, 0, right 1, up 1. So here we go. A horizontal stretch means change the graph. You're going to multiply by 3. So multiply the X by 3. Multiply the X by 3, multiply the X by 3. The Y's stay the same. Up doesn't change the graph, so we're going to add 2 to the Y. So the X stays the same, and we're going to add 2 to the Y, add 2 to the Y, add 2 to the Y, and graph. All right, so left 3, up 3, 0, up 2, right 3, up 3. Look at this. Does he look like he was horizontally stretched? Doesn't he look fat? Okay, so that's the graph. So it does look like it was stretched and up. There was no shifting left or right. And I'm not sure about this, you guys, but I think they're going to ask for the domain and range. Remember domain is where the graph exists left and right. So the domain would be all real numbers. And the range, where does the graph exist? 2 and up. So the domain, if you remember this, exists forever left and right. The range, the graph exists closed on 2, up forever. So just remember with B, you have to take the reciprocal. Okay, would you like me to do one more problem, or are you guys ready to go?
Actually, there.
Can you do
Miss
one
Birch.
more?
Yeah, go ahead.
For the so when it's B, it's always going to be a horizontal stretch.
If it's a proper fraction, if it looks like this, that's going to be a horizontal compression by 1/4.
Okay, thank you.
You get what I'm saying though, right? Like when it's a proper fraction, it's a compression with anything. If it's a regular number that's greater than 1, like even 3.5 or 3 or 4 or 5 or 6, or as long as it's not a proper fraction between 0 and 1, it's a stretch. So on this one, because it's B, we had to take the reciprocal, which made it a horizontal stretch by 3. If you have this problem and you take the reciprocal, it's a horizontal compression by 1/4. If it's a proper fraction, it's a compression. Does that make sense, guys, or no? Can you guys give me some feedback, please? Do you want me to do another problem? You guys okay, or what?
Can we do another problem?
Yeah. You do not see B a lot because it does make the problem messy, I guess. All right, state the transformation. Do you have left or right? What is that? Left or right?
Right.
Right 2.
Right 2.
Okay, I can't say this any clearer, folks. The form has a negative in it. Don't look at the form. So the form has a negative, that's right 2. If it's a plus, it's left 2. Okay, go ahead. What's next? Do you have a stretch
That's only when it's on the
compression?
inside, right?
Huh?
That's only when it's on the inside. Like where like the negative is a right, where the positive is a left.
The form looks like this.
Yeah,
You
yeah.
wrote it down, right? That's a minus. So if there's a minus, it's part of the form. This is not left 2. It's right 2. That's all I'm saying. Is that the form has a negative in it. So if the form has a negative in it, that's not a negative 2. It's right 2. That's all I'm saying. Right?
Yeah.
Every form we use, cubic, cubic, absolute value, logarithmic, exponential, absolute value, all of them have a minus in it. So don't look at the minus. It's in part of the form. This is right 2. If you have something like this, can you see that's not a minus? So you have to put a minus in there, which makes it left 2. Right? Can't get my pen to work. See? See the difference? This is right 2. This is left 2. Because it has to be written in the form. Do you understand or no?
Yeah, I get it.
It's like making a ring. If you want a ring that has a heart, you can't put the gold in a mold that has a star and hope for a heart. These have to be in the form. It has to have a minus in it. If it doesn't have a minus in it, you have to write it in the form. So this would be left 2. This would be right 2. All right, what's next?
Yeah, I get that.
What's next? Do you have stretches and compressions? Yes. What do you have?
A horizontal stretch by 3.
A horizontal stretch by 3 because it's on the inside, right? Right?
Yeah.
What's left? A reflection. A reflection where?
Across the y-axis.
Right, across the y-axis because it's a horizontal movement, right? All right, so here we go. With the right, you're going to add 2 to the x. So add 2, add 2, add 2. Leave the y by itself, alone. Horizontal stretch is gonna change the graph. So you're gonna multiply the x by 3. So multiply the x by 3, multiply the x by 3, multiply the x by 3, and leave the y alone. Okay, now you're gonna reflect y. Well, reflect y is a horizontal movement. So you have to negate the x, negate the x, negate the x. And by the way, on this particular problem, if you do not follow that order, you're going to get the wrong graph. I'm just letting you know. All right, so left 3, up 1. Darn it. Left 6, 0. And I didn't go out far enough. Left 9, up 1 is going to show, it's going to be a horizontal stretch. A horizontal stretch. That was, it was shifted over here first. And then it was reflected. It went like this. It flipped over the y-axis. So it flipped over the y-axis. So it was shifted right, it was stretched, and then this guy flipped over the y-axis. I'm sorry I didn't draw it out. You get what I'm saying though, right?
Yeah.
All right. Can I erase this? Yes.
Yeah.
All right, what I want to do is, before we go into the Math Wizard teams, I just want to make sure you can state the transformations correctly in the right order. So we're going to work on the second part of the assignment, which is the exam practice. So let me get, hold on. Let me open up the assignment. Darn it. I have all these pop-ups. It's taken a month and they still haven't fixed it. Frustrating. Give me classroom, please. All right. This is your assignment. And I want to look at this exam right here. It's not an exam. It's just, we're going to look at it. All right. So it's 10 problems and we're just going to practice stating the transformations. Okay. All right. So number 1, somebody unmute yourself and tell me, what is the transformation on number 1?
Ms. Birch, you're not sharing your screen.
Oh, I'm not? I'm sorry. Ah, darn it. I'm sorry, guys. My bad. Let's see if I could share my screen. Sorry about that. That would help, right? I love technology. It's just so much fun for me. All right, let's try it again now, folks. There, can you see it now?
Yeah.
Yes, no?
Yeah.
Okay. All right, guys. Number one, somebody unmute yourself and tell me the transformation, please.
Right one.
Right one.
Right one. Okay, good job. All right, number two, somebody different.
Up 2.
Good job, up two. Okay, number three, who wants to do it?
Would that be down 3?
Yeah,
No,
but
it's a negative. Oh wait, what?
it's down 3, but you got to get the right order and you missed this negative in front.
Um,
It's outside the square. Everything's outside the square. You don't see anything in a square, right? You don't see anything like this.
So that would
So
be
it's all
reflect
outside the
X, right?
square. So what is it?
Reflect
Reflect?
Reflect
X in down 3. Okay,
Yeah.
somebody on number 4. It's inside. What is it?
Left 3.
Yep, it's H, left 3. How about number 5? Nothing's inside. So what is it? It's just like number 3. We just did it.
Reflect
What is
X.
it? Reflect X and
Up 4.
up 4. Okay, number 6. What's that?
Left one. Reflect over Y.
Yep, it's left 1, reflect Y, because it's all inside. Okay, this one has 3 of them. Who wants to do this one? It has 3 transformations. What is it?
It's left 4, a reflection across the x-axis, and up 1.
That's correct. It's left 4, reflect over the x-axis, and up 1. Okay, how about number 8?
Wouldn't it be right 2, reflect over Y, and up 3?
Up 3. Yep, good job. Okay, dos mas. What about number 9? Somebody different. You have something on the inside and something on the outside. What would it be?
Right 3. Reflect over X.
Yep, good job, Brandon. Okay, how about number 10?
F2 and down 4.
Yep, good job, Aurelia. Good job, babe. All right, so here's what we're gonna do, guys. You're gonna go into your Math Wizard teams, and you guys met each other the other day, right?
wait, you changed the groups?
I changed the groups. Did you guys meet the groups yet or no?
No.
No.
Okay, here's what you're gonna do. When you go into the new teams, you're gonna say whether do you like distance learning or not and why.
Okay.
You're gonna say, I like distance learning because of this, or I don't like distance learning because of this. Okay, you're gonna say one or the other. Okay? All right, so we're gonna have a little conversation. I do want you to introduce yourself, and you're gonna say you like distance learning or you don't, and why. All right, and then you're gonna work on this part of the assignment. And you're gonna do 3 things. You're gonna state the transformation in the correct order. You're gonna show the transformational points, and you're gonna graph. All right? Okay, I'm gonna be taking attendance in the teams, and class is over today at 10:45. So you got some time. Okay, we will not report back here. Okay, so 10:45, it's gonna be a little weird working together because you're not used to each other, but I do want you to warm up quickly to each other. I am gonna be checking to make sure you're working together. All right? All right, I'll see you in the Math Wizard teams.